All right, welcome back everyone to the deep dive. We're going to be talking all about AI today. Seems like every day there's some crazy new development.
Yeah, I know what you mean. Feels like drinking from a fire hose sometimes.
Exactly. And you know, it can be really tough to filter out the signal from the noise. We're hoping to do that for you today, help you make sense of all the latest developments.
Totally. We've been poring over the latest research, all the new models, the benchmarks, the applications. It's a lot, but we think we've got a handle on the key takeaways.
That's the goal, right? I think one thing that struck me is this emphasis on benchmarking. How do we actually know how well these AI systems are performing?
Right. And it's not just about raw performance anymore. We're seeing benchmarks like Arithmetic Bench focusing on specific skills like, well, arithmetic, and there's TAU Bench looking at real-world reliability. And Paper Bench, can AI actually reproduce scientific findings?
Yeah, and Google's Gemini 2.5 Pro, they're really touting its performance on these benchmarks. Seems to be doing very well.
It is, but it's not a simple story. I mean, we saw some mixed results with other models, like OpenHand's LM. And even OpenAI's own Paper Bench showed some inconsistencies.
That's what makes it so tricky, right? Like, how do we really know what these benchmarks are measuring? Even when an AI aces a test, does it really understand what it's doing?
It's a good question. Take Gemini 2.5 Pro again. It's crushing the Math Arena US Ammo benchmark, which is pretty impressive. But then it struggles to provide the full solution, the proof behind the answer. It's kind of like, getting the right answer, but not showing your work.
And then there's this candle test, which seems to suggest that some AI might be overfitting to these benchmarks, like they're just memorizing the answers instead of actually learning the underlying concepts. Makes you wonder if these benchmarks are truly measuring intelligence.
Absolutely. Are we really seeing real understanding or just really good performance on a specific set of problems?
I mean, that's a pretty fundamental question, right? And then, of course, you've got the hardware side of things.
Oh, yeah. K-Transformers, they've got this new setup with Xeon 6 processors and MRDM 8800 memory.
And what's it doing?
Well, they're seeing a significant speed increase. Output speed is up from like 17 tokens per second to 40.
Wow, that's almost double. So that means the AI can process information, generate text, all that stuff much faster.
Exactly. And that has huge implications for real-world applications, right?
Now let's dive into some of the new models that are coming out. University of Hong Kong, they've got Dream 7B, which is a diffusion reasoning model.
Diffusion models are interesting. They kind of start with this noisy image and then gradually refine it into something clear. And this one's supposed to be really flexible, a good balance between speed and accuracy.
And then you've got TTSTAT, which is, well, that's a mouthful.
It is. It's a novel architecture trained in the auditory domain. Basically, it's an AI model specifically designed for working with sound.
Specialized AI, that's fascinating. And Meta, they're not sitting still either. They've come out with multi-token attention, or MTA.
MTA is designed to improve language modeling. It helps AI understand the relationships between words better, especially over long stretches of text.
Makes sense. And looking ahead, we've got Qwen 3 coming out in April 2025.
Mm.
They're focusing on improved reasoning capabilities.
There's also Jamba V1.6 from AI21 Labs. That's got this hybrid architecture combining SSM and transformer models.
Sounds complex. And then you've got Nomic AI releasing Nomic Embed Multimodal, a whole suite of open source models that can handle different types of data. So much happening on the model front.
It really is. Lots of experimentation going on, lots of different approaches to try and push the boundaries of what AI can do.
And then there are all these tools being built on top of these models. It's not just about the AI itself, but how we can actually use it.
Absolutely. We've got Llama Extract, which is designed for building agents that can extract structured data, really useful for things like data analysis and automation.
And then there's Windsurf. That lets you deploy applications using coding agents on Netlify.
Right. And on the more consumer-facing side, you've got Klarna's AI assistant. They're saying it's drastically reduced customer resolution time. So, you know, real tangible benefits there.
Yeah, that's what makes it exciting, seeing these real-world applications.
Mm.
And it seems like the infrastructure is also catching up. Like Hugging Face, they're centralizing billing, making it easier to access and manage different models.
And weights and biases, they're offering free courses on RIG and LLM evaluations. OpenAI has their OpenAI Academy with free tutorials. Langsmith Playground makes it easier to create and test data sets. So yeah, it's definitely becoming more accessible.
Okay, so zooming out a bit, looking at the broader trends, there's clearly a huge demand for compute power.
Oh yeah, I mean, they're even talking about renting out NVIDIA Blackwell chips just to keep up with the demand.
Wow. And then there's this idea that AI creativity is actually outpacing the world. Like, we're struggling to keep up with what these systems can generate.
And that's leading to some pretty bold predictions about the economic impact, how AI is going to drive innovation, especially in science.
Fascinating stuff. And then, of course, there are all the software updates, new features in things like Windsurf, Rucode, Aider.
Lots of advancements in how we deploy these models, too. K-Transformers v.2.4 now supports multi-concurrency. New agent frameworks like OpenHands Cloud and general agents are emerging.
Even OpenRouter, they've
Yeah.
officially gone live, although it sounds like there have been some API errors reported. So a few bumps in the road.
Yeah, but that's to be expected with such rapid development. I mean, it's really moving fast.
So just to sum it all up, the world of AI is changing at an incredible pace.
Hmm.
We're seeing breakthroughs in benchmarking, new and innovative model architectures, powerful new tools for developers, and a whole ecosystem that's evolving to support it all.
It's really a fascinating time to be following this space.
It is, and it leaves us with a lot to think about. With all these advancements, what are the potential future applications that you find most exciting, or maybe even a little bit scary? What kind of world are we creating with these technologies? That's something for all of us to consider. Thanks for joining us on this deep dive.
Thanks for having me.